Hello everyone, my name is Dmitrii Ivashchenko and I am a software engineer at Games. I specialize in mobile game and backend system development for over a decade, and I am a member of International Game Developer Association and an author of articles on Medium and Hacker Noon. And let's talk about the pillars of our tech stack that ensure our operations run smoothly and efficiently. First on the list is our CI/CD organization, which is the backbone of getting a large development team up and running comprehensively. This setup ensures that integration and delivery happen seamlessly, allowing for frequent updates without disrupting the user experience. Next, we focus on backend infrastructure, preparing it materials for scalability. As our user base grows, it's crucial to have a backend robust enough to handle increasing load while maintaining performance. And finally, let's not forget our blue-green deployment strategy. This method allows us to release new versions of our software without having to pause for maintenance or technical works. It means zero downtime and a smoother, more reliable experience for our users. Altogether, these elements form an integrated approach to development and deployment, setting the stage for both agility and reliability. Let's start with CI/CD organization. In our technology stack, we've adopted some of the industry's best practices to ensure a seamless and efficient deployment process. We operate under the infrastructure as a code paradigm, which allows us to manage and provision our technological infrastructure through machine-readable definition files, thus enabling rapid deployment and version control. For the sake of environment reproducibility, particularly for continuous integration and staging, we utilize containerization techniques. This enhances both portability and consistency across all stages of development. Further bolster our testing efforts, we employ an emulator farm that allows us to simulate various scenarios and environments. Simplification is a key in our approach, as we've streamlined the deployment of both test and production replay servers to be as easy as a single click. Finally, we conduct a comprehensive suite of checks at the merge request stage to ensure code quality and functionality. These practices collectively contribute to a robust, agile, and highly dependable development ecosystem. So, we use versioning to track changes in our infrastructure as a code. It providing us the ability to revert the previous stages effortlessly. Typically, we use Git. Second, automation is at the heart of our operations. It frees us from manual toil and allows for agile adaptation. Third, our use of code for describing infrastructure guarantees repeatability and consistency. It is making transitions from testing to production environments seamless. And fourth, our code doubles in our documentation. It offering transparency in understanding how our infrastructure is set up and configured. Fifth, scalability and making adjustments are straightforward efforts. We simply modify the code and apply those changes, effectively future-proofing our infrastructure. Lastly, our code-based approach enhanced collaboration among team members and enables rapid responses to ever-changing business requirements. These guiding principles form the cornerstone of our efficient, reliable, and agile infrastructure management strategy. So with teamcity, you can store all your configurations using Kotlin DSL. With GitLab, you can do the same with YAML. And GitLab also offers convenience of performance checks after pushing. teamcity serves as a linchpin in our CI/CD architecture. It brings several advantages that streamline our development and deployment processes. One of its key strengths is a seamless integration with a wide array of version control systems such as Git, SVN, and Mercurial, and that ensuring that our development workflow remains fluid regardless of our choice of version control. Additionally, teamcity's settings system is exceptionally flexible. It allows us to tailor our CI/CD pipelines according to specific needs and conditions. That truly sets it apart, though it's a capability for parallelization and distributed builds. teamcity dramatically accelerates the build process by intelligently allocating tasks across multiple agents, thereby reducing time to market and enhancing productivity. These features collectively make teamcity an invaluable asset in our quest for a more agile, efficient, and reliable tech environment. GitLab runs a series of tasks automatically for your project every time changes are made. It's ensuring continuous code testing and readiness for deployment. GitLab CI allows you to automate various strategies of the deployment lifecycle, from code testing to building to deployment to production. One of its key features is the ability to create complex pipelines with multiple parallel and sequential tasks. It making GitLab CI a powerful tool for development teams. Configuration is described using the GitLab CI.uml file, and it making the setup process transparent and easy customizable. GitLab CI is closely integrated with GitLab itself, that simplifying the setup, monitoring, and management of all aspects of CI/CD. In autobuilds, builds are added for which automatic building is assigned based on certain conditions, for example, based on time. At the moment of the trigger for automatic building, critical validation and building of server configs are carried out first. After that, the server is built and clients for the three main platforms are also built. And after successful completion of the builds, the server is launched. After the server is successfully launched, the client versions are uploaded to the App Center, so they can be downloaded lately to devices. Thus, thanks to autobuilds in the projects, a fresh client-server pair with the latest changes that have been uploaded appears every 1 or 2 hours. Here's the steps to build a server. First, assemble the server configuration, then they'll build the server based on these configurations, and finally deploy the server. This functionality is convenient for testing new features, fixing bugs, or conducting experiments in an isolated environment without affecting the main development process. As a result of the build, the server configuration, server, cloud virtual machine are created and the server is launched. A unique name for a virtual machine is assigned to each user in teamcity. And in the client, you can select a login address from the list of shards to connect the server. Created servers are deleted twice a week, on Thursday night and Saturday night, and thus creating on-demand servers provides flexibility and autonomy in the development and testing process. The development process utilizes a merge request system to ensure that individual changes do not break builds or obstruct the others' work. Developers create a new branch from an updated develop head, make some commits related to specific tasks or bugs, and then push these changes to the target branch. A merge request is then created either immediately after the first push or right before merging into develop branch. The merge request undergoes various automated checks and possibly manual reviews. Once approved, the merge request can be automatically merged when all tests pass, freeing the developer to move on other tasks. If a merge request becomes outdated or irrelevant, it's essential to close it to prevent clutter and confusion in the list of active merge requests. The validation system serves as an integrated tool within a Unity project for validating assets and configurations. Within its interface, user can execute predefined or custom validators or select selected assets or groups of assets. Validators examine specific aspects of an asset to ensure its integrity, such as broken links. It can be marked as critical to enforce checks during build and merge request pipelines. Results are displayed at the bottom of the window and any errors logged in Unity. So the next big part of our CI is Git hooks. The client hooks system consists of several components, including the installer, commit message, pre-commit, post-commit, and post-rewrite hooks, each serving a specific function in the version control workflow. The installer is a binary that automatically downloads and updates these hooks from central repository, placing them in local.git/hooks directory. And it also creates scripts to trigger the hooks and keep them up to date. Commit message checks the commands attached to the commits. Pre-commit performs a variety of file checks, and post-commit and post-rewrite mainly handle notifications after a commit or rebase operation. The protected branch hook restricts pushes to certain branches, essentially making them read-only and preserving their integrity. The rebase required hook ensures that before you can push your changes, you must rebase to have the most up-to-date version of the repository, thus minimizing conflicts. The new branch name hook validates the naming convention of new branches. Lastly, the message content hook enforces standardized commit message through the use of regular expressions. These hooks serve as proactive measures to maintain a high standard of coding practices. Now let's dive in our backend infrastructure. In the architecture of the platform, a variety of tools and frameworks are employed to ensure efficient and robust operation. Eclipse vert.x serves as the backbone for the messaging system and also provides clustered storage for runtime data, offering a scalable solution for high-speed data handling. Complementing vert.x is Hazelcast, an in-memory data grid that enhances performance and scalability. For data streaming and log management, Apache Kafka plays a crucial role as a data broker. It's allowing for real-time analysis and monitoring. On the database side, PostgreSQL is used to store persistent data that's offering flexibility in data storage approaches. Lastly, Ansible is utilized for automating server applications configuration, and it's ensuring that the platform's diverse services are seamlessly integrated and easily manageable. The architecture of the platform consists of several key components designed to handle specific functionalities. The account server is responsible for user authentication and maintains information regarding all connected game servers. Next, the game server is a central hub for all game mechanics, logic, and data. That's ensuring that gameplay experience is consistent and engaging. And on the administrative side, gametool web serves as a comprehensive tool for managing both player accounts and server settings. Lastly, gametool ETL works behind the scenes and funnel game logs from Apache Kafka into gametool database, thereby enabling robust data analysis and reporting. This HTTP server has its own database and consists of several components. The authentication component is responsible for user authentication and distribution among the game servers and their front-end components. The billing component processes in-game purchases, and the game server configuration component is used to communicate with game servers, announce maintenance, and perform other related tasks. The server comprises a cluster of either physical or logical nodes, each made up of multiple components and services that interact seamlessly through a common event bus. At the front end, we have the front-end component, responsible for managing TCP connections and verifying clients via the account server. It serves as the main gateway for client-server communication. The dispatcher queues and delegates client's requests and messages to the appropriate parts of the system. Scheduler plays a crucial role in time-sensitive game mechanics, providing timed subscriptions to various components. Our DB operation executor ensures smooth and asynchronous interaction with databases, while the resource system holds the configuration for game mechanics. Moreover, all server activities are diligently logged by our log system, which sends these logs to an Apache Kafka message broker for analysis. The server also hosts an array of specialized mechanical components, such as those for missions, quests, and mail, making it a comprehensive and flexible platform for an immersive gaming experience. Our game tool is an essential part of our comprehensive game management ecosystem. It consists of two pivotal components. First is gametool ETL, which stands for extract, transform, and load. This component is responsible for siphoning off game logs from our Apache Kafka message broker, processing these logs, and then persist the transformed data into its own dedicated database. This ensures that we have a streamlined, reliable repository for game analytics and insights. The second part is gametool web, an administrative tool designed to offer a real-time access to essential server data. The gaming platform incorporates a range of specialized services to enhance user experience. Photon is utilized for PvP and cooperative gameplay, while Leaderboards offers a universal system for storing and ranking player achievements. The friend service takes care of the list of friends and provides referral information. Each player also has a player profile, which gives a detailed account of their in-game activities and statistics. The replay service is It's a tool for store gameplay replays. Additional functionalities includes mail for in-game messaging, chat for broader social interactions, including group settings, matchmaking for effectively pairing up players as opponents or teammates, clans for organized group activities, and push notifications to keep players updated while real-time information sent directly to their devices. Our current architecture combines various systems and components coordinated through Photon Cloud for real-time multiplayer gaming. Photon Cloud offers low latency data centers worldwide, and its versatility expands to applications beyond gaming like text and video chat. Our primary data storage is PostgreSQL because we find that relational databases are generally more reliable and easier to validate than other data storage models. For message brokering, we use Apache Kafka due to its out-of-the-box horizontal scaling and high reliability. We also use Hazelcast as in-memory database that integrates with vert.x, our framework for building reactive applications. Our tech stack includes vert.x, which supports multiple programming languages and operates a reactor pattern. Despite of its benefits, vert.x can lead to complicated code, especially if the language I'm using isn't fully supported by the framework. In such cases, alternatives like a Quasar project could be considered, although Quasar wasn't being actively maintained when we began our project in 2017. For transactional operations, we've created a custom object that allows linear operations within message processing. This approach covers most of our use cases. During testing, we discovered and reported a lock queuing issue in vert.x, which the developers have since addressed. We monitor performance metrics using Prometheus and visualize them using Grafana. This setup helped us fine-tune our vert.x configuration and resolve bottlenecks. Our game cluster is a collection of machines running instances of vert.x and Hazelcast, with each node running various game mechanics. These mechanics are encapsulated in vert.x verticals, which have different tasks like game model loading or arcade tasks. To manage all these, we use a comprehensive admin interface. Scaling for performance is relatively straightforward. Our current hardware can comfortably support 150,000 users, and if we reach CPU limitation, we can add servers to the cluster, and our PostgreSQL setup might be the first bottleneck in terms of scalability, but different synchronization with Hazelcast can elevate this issue. Now let's review our blue-green deployment process. So why we choose to employ a blue-green deployment strategy for our operations? This decision to go with this approach wasn't taken lightly, as it does come with its own set of architectural and operational costs. However, in our specific context, the advantage clearly outweighed these expenses. There are two main reasons behind this decision. First and foremost, downtime is not just inconvenient, it's expensive. Even a minute of downtime can have significant financial implications for us. And the second reason is unique to our focus on mobile games. When we publish a new version of our mobile game client, it needs to go through a store review process, which isn't instantaneous and can take several days. This means we absolutely need the ability to support multiple game servers instances concurrently to align with the release cycles of mobile app stores. So the blue-green deployment strategy provides us with the flexibility and reliability we need to meet our business requirements. Our setup involves three main elements: the client and two servers, named alpha and beta. The objective is to transition the game traffic seamlessly from alpha to beta, all while ensuring that the players experience zero interruptions. This discrete migration process involves not just the game service and the clients, but also specialized account server. The sole role of this account server is to provide the client with appropriate game server address for connection. It also keeps track of the server status, which is essential meta information that helps coordinate the switch. The goal is to make this transition as smooth as possible, so players remain blissfully unaware that any change has even occurred. Let's walk through how our game update system achieves zero downtime, ensuring an uninterrupted game experience for our players. Initially, alpha server is live while beta is stopped. When a player enters the game, the client contacts the account server to find out which game server is currently active. The account server responds with the address of alpha, and the client connects accordingly. Now, when it's time to update, alpha is declared as stopped and beta is set to live. Alpha then sends a reconnect broadcast to all its connected clients. On receiving this, the clients re-establish their contact with the account server, which now provides the address for beta. The client switches its connection to beta seamlessly, all without the player noticing any disruption. Through this coordinated dance between the account server, alpha and beta, we effectively achieve zero downtime during server updates. There are some areas for further enhancements. First, our quality assurance specialists have expressed the need for a final testing phase on the new version of the game server before players are allowed to join. Second, we want to allow the client to complete certain activities on the same game server where they started. To facilitate these improvements, we introduced a new server status called staging. During this staging phase, access to the game server is granted to a select group: our QA specialists for rigorous final testing, and ordinary players who specify their preferred game server during the login request. This added layer of sophistication ensures both quality control and enhanced user experience. This is how our enhanced game update mechanism works, as illustrated in the given example. Initially, alpha is live and beta is stopped, with clients connected to alpha. The first change occurs when alpha remains live, but beta transitions to a staging status. This allows our QA team to perform final tests on beta while keeping the bulk of the player traffic on alpha. Once beta clears QA, it becomes live, and alpha switches to staging. At this juncture, alpha sends out a broadcast reconnect event. However, if a player is engaged in an activity like battle, the client has the option to ignore the reconnect signal and stay on alpha. Finally, when alpha transitions to stopped status, any new login attempts are directed towards beta. And this scheme offers flexibility for various update scenarios whenever we are rolling out a completely new game version or simply pushing updates to fix bugs in existing version. This ensures both robust quality assurance and uninterrupted gaming experience for our players. While having multiple versions of servers running could technically allow players who haven't updated their game to continue playing, it introduces a complexity. The need to maintain both forward and backward compatibility across different system components like databases or inter-server interactions. And to simplify this, we've adopted a strict responsive policy. Client of version X will only connect to server of the same version X, and similarly for version Y. This approach eliminates the need for double work in maintaining protocol compatibility. Within the same version, server changes are permissible as long as they don't affect the client interaction protocol, giving us room for operational flexibility. As a result of this, the account server now needs to be aware of game server's version, and the client is required to specify which version of the game server it wishes to connect to. This streamlines the system while allowing us ample space for ongoing improvements. So, version 2.0 is slated to replace the existing 1.0. Once our QA specialists have given beta the green light, we initiate what we call a soft update. During this phase, beta goes live, and a fraction of players gain access to the 2.0 client via their respective app stores. If all goes well, with no critical bugs, we expanding this to 100% of the player base. Contrary to the blue-green deployment strategy, the server from previous version doesn't initiate any reconnections when a new version is rolled out. Now, if any issues surface, we employ the blue-green deployment process to transition players to third server, Gamma, which contains the necessary fixes. Meanwhile, players on the 1.0 client can continue their session on Alpha. Ultimately, we initiate a hard update, shutting down Alpha and halting all 1.0 login attempts. Players are then prompted to update their clients to continue playing. This nuanced approach not only ensures a smooth transition, but also incorporates contingency plans for unexpected hiccups. Our server update process has been streamlined to such an extent that it's entirely managed by our QA specialists using a straightforward gametool interface. Here is how it works in a nutshell. The account server, which holds its complete stage in a database, it's entirely stateless, making it highly robust and flexible. A QA specialist uses the gametool to instruct the account server to change beta status from stopped to staging. This is where a final check takes place, and once beta is confirmed to be live, the same QA specialist uses gametool to prompt Alpha to send a reconnect signal to all connected clients, initiating their migration to beta. This approach offers a simplified, user-friendly method for QA specialists to manage the complex project of server updates. That's ensuring a seamless player experience while maintaining the integrity of our game servers. This approach not only allows us to roll out game service updates without downtime, but also enables us to quickly address game mechanics, bugs, and optimizations. Imagine a scenario when a critical error occurs during a particular game activity. Players aren't left at large, and they can still enjoy their aspects of the game while we rapidly deploy a fix. This ensures that their next attempt at the original game activity is likely to be error-free. Another advantage that deserves special mention in our ability to fix client-side bugs through the server. This is critical because updating the mobile client through the App Store takes time, and that's making client-side bugs potentially more damaging than server-side ones. There have been instances minor adjustment to server responses effectively convince the client to behave. While we can't always count on such fortunate outcomes, our blue-green development system remains our safety net even in the most unexpected of situations. So let's make some conclusions. In summary, the three pillars of our tech stack work in unison to create a highly effective, agile, and dependable ecosystem for both deployment and development. First, our CI/CD organization acts as a spine of our development structure. It not only integrates a large team, but also allows for seamless update without affecting the end users. Second, our backend infrastructure is flexible, explicitly engineered for scalability to meet the demands of a growing user base without sacrificing performance. And finally, our blue-green development strategy that ensures zero downtime during software updates, giving our users a seamless and reliable experience. Collectively, these pillars establish a technology environment that is both state-of-the-art and extraordinarily reliable. Thank you for your attention and see you next time.